Hi there, welcome to another edition of Kung Fu Physics, where we are working our way currently through practice physics GRE problems. I have another mechanics problem for you today. It's number 54 off of the 2001 exam, and it's a very easy, very short problem. So let's go right into it. Looks like this. That's number 54. I'll glance at the answers really quick, and they don't tell me too much. It's just 0, 1, 2, 3, and 4. Units are the same. To me, the units look like something like a momentum, right? So, go right into it. Number 54, you could take a quick glance at the diagram before you read it. And then 54. The figure above shows a plot of the time-dependent force, F of t, acting on a particle in motion along the x-axis. What is the total impulse delivered to the particle? It's F sub x of t is the force there. And so the only reason that this problem would be challenging, I would say, and the only reason that the test makers put this problem in there, I think, is just to give you a check, see if you remember what impulse is, as a physicist understands impulse. It's a really easy concept, though, really easy. So if you've clicked on this problem and are watching this, maybe you forgot what impulse is. It might not hurt to just review it a little bit. But the simplest thing, I wrote this beforehand. I don't even have to do any calculations to solve this problem, thankfully. But as a reminder, this is what impulse is. It's a force acting on an object over time, and you sum up, you integrate over that time what that force is. So impulse is sort of interesting. It does, when I looked at the answers, they have units of momentum. It does have the same units as momentum, so you know. But other than that, it's just, that's it. I mean, this is what impulse is. I guess I probably have a couple more problems regarding impulse. I think there's one about that uses the rocket equation and stuff like that I'm going to be getting to shortly here. So I'll probably elaborate more in some of those other problems. So look for that. But for right now, that's, I guess, all I have to say about it. So it's an integral over time, and in the problem, you look carefully, I mean, they've set it up actually very nice for us. There's really not that much of a trick to it. You've got time on the x-axis and the force on the y-axis. So you would just need to integrate whatever your function was for the force and get the area under that curve. But there's nothing sloppy you have to do because it's just a triangle, right? You don't actually have to integrate. You just need what is an integral. You just need the area under the curve, right? So what is the area under that curve? Well, you can just look at it. It's two triangles, and the base of this first triangle, the one that's furthest on this side, let's start with, I mean, they're the same triangle. So when you start here, it's just 1 times 2, half of that, so that's 1. The area of 1 on the first triangle, and there's two triangles, they're the same. It's an area of 2. So I don't see why you would mess that problem up. You just pick answer C, 2, and get on with it. This falls into the category, I would say, of a problem that you could probably do in 30 seconds or less. I mean, really, it's just whatever it takes you to read the problem, as long as you remember what an impulse is. So there you go. If you didn't remember before, you got a little bit of a refresher. And I think there are some other problems. It wouldn't surprise me, though, if this is the only problem specifically about impulse on that year's exam. And so there's probably like something like one sort of mechanics problem per exam on something like impulse. So that's all. As always, thanks for watching, and best of luck in your studies.